So in this video, we're going to talk about finding unit vectors when it's written in the form parallel, perpendicular, in the z direction. Okay, and this is where it gets a little bit tricky. These problems tend to be a little bit harder, but again, we're going to break it down. And I promise you, if you follow the way I do these types of problems, then the problem becomes fairly easy. So we have the vector here, the gravitational vector. Okay, and we know that phi is 21 degrees. So how do you find the unit vector, the perpendicular component and parallel component? Well, I always follow these two steps. So the first thing I do is right at the point of the tail of the vector, I draw a perpendicular line. So here's my perpendicular line, but I'm going to draw another one right there at the tail of the vector. So if I take out my ruler, okay, and I draw a perpendicular line right at the tail, then I have something that looks like this. So there's my perpendicular line, okay. Now the good thing about this is that my parallel line is already given, okay. Now what I'm gonna do, I'm gonna draw two arrows to signify my stopping point in the parallel direction, and it doesn't matter where, but I'm gonna show you the reason why I do this. So I'm gonna draw an arrow here. So maybe I have an arrow here, okay, and maybe I have an arrow here. Now I want you to look closely, excluding this parallel line here, which is now useless, okay? You see what we've created? We've created the picture in such a fashion that it becomes easy for us to read now, okay? So this parallel line now becomes very irrelevant, okay? So now if I'm looking at this, I'm saying to myself, okay, well, if phi is 21 degrees, we know this right here is a right angle, so we know that's 90 degrees, and the sum of the angles in a triangle have to add up to what? 180 degrees. So therefore, if I want to find this angle, if I have 90 degrees, I have 21. Well, if I take 180 minus 90 minus 21, I get this angle to be 69 degrees. And hence the sum of the angles in a triangle will add up to 180. Okay, so we know this angle is now 69 degrees. Okay, well, that's nice to know. So now what becomes our parallel and perpendicular unit vector? Well, we know that's cosine, yeah. So if I look at this, if I want to find the parallel component, this is cosine theta. Well, in this case, it's phi. So cosine phi parallel, cosine phi perpendicular. And then we know in the z component, since we're doing parallel and perpendicular, this is just 0. Okay, so now the idea is now we just got to find phi. We got to find what phi is. So if I'm looking at a perpendicular direction, remember it's always from the axis, the perpendicular axis to the vector itself. Now there's two ways of doing this. You could go in the negative direction, which is clockwise. Okay, or you could go in the positive direction, which is anti-clockwise. And typically I like to keep my stuff positive in the anti-clockwise direction. So I'm just going to go this way. So starting from the parallel component, if I go around in the positive direction, I hit a 90. If I go one more, that's a 90. If I go one more, that's a 90. Okay, and this angle here, we got to pass this angle in order to get to this. Well, think about it. If this is 69 degrees, and we know each quadrant will always add up to 90 degrees, then if this is 69 degrees, that means that this little piece right here, sorry about this, guys, have to be 21 degrees. Okay, it has to be 21 degrees. I simply take 90 minus 69, that will be 21 degrees. So going from the parallel component, this is 90 plus 90 plus 90 plus 21. So therefore, in the parallel component, this will be cosine of, well, if this is 90, 90, 90, that's 3 times 90 is 270. So we take 270 plus 21. And that will be the component in the parallel direction. Now, in the perpendicular direction, it's a bit different. Right, in the perpendicular direction, I'm looking at something different. So if I look at this in the perpendicular direction, I'm actually going, this is 90 plus 21. Yeah, because we move 90. Okay, we move 90. We also move another 90. And what's this little piece here? 21. So this would be cosine of 180 plus 21. And then we know the z component is just 0. And so if I do the math, cosine of 270 plus 21, well, in the parallel direction, that is just 0.358. If I do cosine of 180 plus 21, that would be negative 0.934. And then we know in the z direction, that's just 0. So this would be the unit vector of the gravitational force in this case. Okay, so notice how we just break that down. Okay, so let's look at another one to kind of get this concept and how I approach these problems. So what if we're given one like this? Okay, what do we do? Well, remember, the first thing I like to do is draw a perpendicular line at the tail of the vector. Okay, so perpendicular line is right here, and you could see if I draw a line perpendicular to this, it's going to be in the same direction. So at the tail, if I look at this and I draw a perpendicular line, okay, at the tail, now this looks something like this. Okay, there goes my perpendicular line. Okay, there's my perpendicular line. So this is the perpendicular line. Now, this is where I'm drenching up all your geometry here. Remember alternate interior angles, and that's why, you know, when your teacher said you will see this again in college, you shouldn't have laughed at her. Okay, because it was actually true. Okay, remember alternate interior angles. If this angle is theta, then we know by alternate interior angle, this angle must be theta also. Okay, so that's just something that doing these problems you need to know. Okay, so now that I have my parallel line, my perpendicular line, I'm gonna draw two arrows to signify my stopping point to kind of get the picture in full sense. So if I draw an arrow here, and maybe I should draw an arrow here, and look, if you look exactly at the picture, now I'm just looking at, it's like a regular unit vector straight problem and not incline anymore, where you're getting confused. Okay, so now that I'm looking at this, I know what theta is. So therefore, if we want to find the unit vector a hat, we know in the parallel direction, that's just cosine of theta parallel, and the perpendicular direction is just cosine of theta perpendicular, and in the z direction, that's just 0. Okay, now the idea is now we got to figure out what these angles are. So again, coming from the parallel component, I'm always going to go in the positive anti-clockwise, simply because I don't want to have to deal with negative and negative direction. Okay, so from the parallel component, I go a 90, and I also go, well, let's see, the sum of the angles in one quadrant is adds up to 90, right? Because remember, now we're looking at type of a unit circle problem, and so remember, the unit circles are 360 degrees with 4 quadrants. So therefore, if I divide 360 by 4, one of those quadrants, the angles must add up to 90 degrees. And so in this quadrant here, we know the angles add up to 90 degrees. And we know if theta is 25, then if I take 90 minus 25, I get 65. So this little piece here will be 65 degrees. So therefore, when I'm looking at the cosine of the angle for the parallel component, this will actually be cosine. So this should actually be cosine of 90, which we go 90 here, plus 65. Okay, that would be cosine of 90 plus 65. Now the parallel component, we simply go here. Okay, so the parallel component, perpendicular component, we simply go to perpendicular line, and we just go all the way down to the vector itself. And you could see we just said this was 65, so this is just cosine of 65. And you know the z component is just 0. Okay, so I plug this in my calculator, I get cosine of 90 plus 65. Okay, well, that's nice to know. And we know the unit vector will be negative 0.906. Okay, cosine of 65, that's just 0.423, and then this is 0. So there's our unit vector. So again, this is how I approach my problem. Draw a line perpendicular to at the tail of the vector, and then draw two arrows to signify the stopping point, and that clears up your problem magnificently. If you guys want another video of practice problems, give this video a thumbs up and just comment down below, and I'll definitely I have several of these problems that I could just make practice problems for you guys.